Hello, good morning everyone. Welcome to another episode of Xa Talk Show. Today is Advent of Code, Day 2. Okay, we are going to get right onto it. Let's see. Advent of Code, Day 2 in Wolfram language. Okay, so check out yesterday, that's Day 1. Okay, so let's start coding Wolfram. If you are here, say hi, okay? So Advent of Day 2, so let's just get straight to it. So Day 2, that's the right answer. Okay, that's Day 1. Return to Advent of Code calendar. Let's say Day 2 and move here so you can see. Oh yeah, so switch screen. So there it is, the Day 2 problem. Okay. Okay, you are launched high into the atmosphere. The apex of your trajectory just barely reaches the surface of a large island floating in the sky. Hello guys, starting to come in. So this is my keyboard, Kinesis 360. Okay, search Xali Kinesis 360 keyboard. You'll find my YouTube review and my website. And this is Ultimate Hacking Keyboard. Both are great, okay? So, Day 2, Cube Conundrum, solved in Wolfram language. You are launched high into the atmosphere. The apex of your trajectory just barely reaches the surface of a large island floating in the sky, okay? So, you gently land in a fluffy pile of leaves. It is quite cold, but you don't see much snow. An elf runs over to greet you. Okay, so the elf explains that you arrived at Snow Island and apologizes for the lack of snow. He'll be happy to explain the situation, but it's a bit of a walk, so you have some time. They don't get many visitors up here. Would you like to play a game in the meantime? As you walk, the elf shows you a small bag and some cubes, which are either red, green, or blue. Okay, a bag of red, green, or blue. Each time you play this game, he will hide a secret number of cubes of each color in the bag. Okay, and your goal is to figure out information about the number of cubes. So he's gonna hide some of the cubes. Some red, some blue, some green. Red, green, blue, right? You need to figure out how many are each. So to get information, once a bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, show them to you, and then put them back in the bag. He'll do this a few times per game. Okay, for each game, it's a bag of cubes of different color. He's gonna grab some, show it to you, put it back, okay? Now, you play several games and record the information from each game, your puzzle input, okay? So each time he show you, you record it. That's your input. Each game is listed with its ID number, like the LL in game LL. Game 11, what is game LL? Incomprehensible. Okay, each game is listed with its ID number, followed by a semicolon separated list of subsets of cubes that were revealed from the bag. Okay, each game is listed with its ID number. Okay, followed by a semicolon separated list of subsets. List of subsets separated by semicolon of cubes that were revealed from the bag, like 3 red, 5 green, 4 blue, okay? But he uses comma, that's not semicolon. So for example, the record of few games might look like this, okay? That's like your input. So let's write it down. For example, show in browser. So this is today's Xa Talk Show YouTube link. Let's linkify it, show in browser. Okay, so that's your so let's look at the input. Game 1 Okay, that 1, 2, 3, 4, that's the ID number, idiotic. So game 1, 3 blue, 4 red. Oh, okay. So in each game, he does this, the elf does this a few times. Each time shows you some cube with their color. How many are there? So first time 4 red, 4 blue, 3 blue, 4 red. Second time 1 red, 2 green. Third time 6 blue, 2 green. That's the first game. He showed it you 3 times. Okay, so game 2, same thing. Okay. So each game he show you several times. Each time is how many blue, how many red, how many green. Okay. In game 1, 3 sets of cubes are revealed from the bag. 3 sets of cubes revealed from the bag, then put back again, right? Okay. The first set is 3 blue cubes and 4 red. 3 blue, 4 red. That's right. Okay. And the second set is 1 red, 2 green, check, and 6 blue, check. Okay. The third set is only 2 green. Okay, check. Understand the problem. Okay. The elf would first like to know which game would have been possible if the bag contains only 12 red cubes, 13 red, 13 green, and 14 blue. Okay. Let's see. The elf would first like to know, implying there's more than one question maybe. The elf would first like to know which games would have been possible if the bag contains only 12 red, 13 green, and 14 blue. Which games would have been possible? Okay, so you require some thinking here. So if the bag contains 12 red, 13 blue, 12 red, 13 green, 14 blue, that is the whole set of cubes. Okay, that's a whole, complete, total. So each time he's gonna grab some, show it to you, put it back, mix, grab some, show it to you, put it back, do it a few times. Now, the elf would like first to know which games would have been possible. So what does possible mean? Well, obviously for one case is that if he showed you 100 blue, then if the bag only contains 12 blue, then that's not possible, right? So given this information that there are a total of 12 red, 13 green, 14 blue, you can eliminate any of the game and any of the draw. If there's more color than in the bag, then that is obviously not possible. Now, there's a question. Once he draw it, does it put it back? I think he does. Let's see. Let's double check, okay? So to get information, once the bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, show them to you, and put them back in the bag. He'll do this a few times per game, right? So he will put it back. So, okay. So I have a clue what is the first thing he wanted to know. So it's just basically counting. Let's see. Yeah, so for example, let's take game 1. The first draw is 3 blue, 4 red. Now, if any of this number is more than the color in the bag, then that's not a possible game, right? So you check that one. Game 1, for each game, there are several draws. So for each draw of a game, you check if it's, if there's more than color in the bag, then that means this whole game is not possible. So you you don't have to continue with the other draws. As soon as you found one game, one draw that has more color than is possible, then eliminate that game. Okay, that's probably what he's asking. So in the example above, game 1 to 5 would have been possible if the bag had been loaded with that configuration. What? However, game 3 would have been impossible because at one point the elf showed you 20 red cubes. Let's check. Game 3, there is 20 red. However, it says there are only 12 red. Okay, check. So obviously game 3 is not possible. Okay. If you add up the IDs of the game that would have been possible, you get 8. Okay, so basically the question is which game is not possible. Okay, this summing idiocy, this advent of code likes to get the answer by sum them. It's one kind of way to verify. So this is like a binary bit checking. It's correction code. So you sum them up. If the number matches, then you kind of know you got the correct answer. But this is not the perfect way to validate correct answer. For example, in this question, you could ask the puzzle solver to list all the games that's not possible. Just a list of numbers. That's one way to verify it. But as far as I learned, this advent of code has a habit always like just sum it up, get a number. So, well, maybe because that's easier to check, because then you have to do the website, you have to validate the answer. If it's just a number, it's easier. Yeah, but with a number, it's possible to have ambiguities. So, for example, let's say for this test input, the correct answer is 8, it says, right? But how many possible ways for a bunch of integers that sums to 8? You can have 1, 7, you can have 2, 6, you can have 4, 4, right? You can have 3, 5, right? So there are many possible ways to sum up to 8. So you might get it wrong, but you still get the right answer. So this is ambiguity in the design of the puzzle. That's a criticism of the puzzle. Okay. So anyway, so let me read the comment in a bit. Okay. So first question: determine which games would have been possible if the bag had been loaded with only 12 red, 13 green, and 14 blue. Okay. Now there is another issue with the puzzle representation, because now this sentence 12 red, 13 green, 14 blue is repeated. Once it repeats, then you have to double check. Is that the same thing? Are you just are you just repeating for emphasis, or just reminding us, or is it some new value? Okay, criticism about the writing of the puzzle and design of the puzzle. Okay, but anyway, so you need to find what would have been possible. Okay, so find the possible games, sum their ID up. That should be the answer. What is the sum of the ID of those games? Okay, so basically for the test input, it's 8. Now you need to get your puzzle input. Okay, let's get our puzzle input. Okay, select all. Now we did this yesterday. We know. Let's open a new file. Let's save it to a file because, it's actually not too big. Only 100. Okay, let's. In that case, we don't need to. Okay, so let's just input equals to that. Okay. So it's just 100 lines. Okay, game 1. Okay, so that's Wolfram code. Let's put a semicolon so it suppresses printing this expression. close that. Okay, determine which game. Okay, we know the what is a puzzle. Now the problem is to, let's write code. Take off your clothes. So let's read the comment a bit. I also have Logitech. Yeah, Logitech 502 is fantastic. I recommend it. Go to my keyboard blog and go to mouse, and here is my recommendation of mouses. Buy it from Amazon from my affiliate link. Okay, let's see. I don't want to interrupt your flow or thought process with what is this? While solving the problem for the first time. Okay, yeah. You probably solved it already, I assume. Okay, let's get back to the code. Okay, so let's close that. Okay, copy. Let's put the link here. Okay, so back to the code. Now, close that. Now. Okay, so now you got a bunch of lines. Okay, you first of all you want to pass out the game ID. Well, so you see, well, let's start code. Okay, first of all, split lines. Split the input. Then you got a list. Okay, so the length of the list is a number of lines. Okay. So you just print it. Let's run it. Okay, so you got a long list, right? So, okay, put a semicolon and you can say length, okay? Print it. So you can see, what? 2352, we split it wrong. So string split, you need to have, by default is split by white space. So now you need to tell it to split by the new line character. Okay, run it. 100. So that's correct. Game 100. So once you split, then you take out, so you don't need the game ID because it's just the index. Okay, so you take out the, remove the game ID, then you split again. You split by the semicolon. Okay. Let's see string part. String part is like taking a substring. In most programming languages, they call it substring. Okay, so let's turn on JavaScript. Let's look at the documentation. So string part. Okay, string part takes a substring via the position of the string, via the index of the string, which is not what we want, because we want some kind of pattern to remove, because game 1 and game 100 they have different length. So we want string take. Let's see, string take, does it take a regular expression? No. We want string drop, string position, string starts, string partition. Let's see, string drop. No, those are all go by position. So now go to some Wolfram tutorial. Let me introduce you again. My Wolfram tutorial. You can click on this link to download Wolfram engine for free, so you can run it just like I do and learn it from my Wolfram language tutorial. Okay, this is kind of complete for programmers and unique. You won't find that, because usually other Wolfram tutorials, Mathematica is like teaching you math, calculus, solving equations, or do physics or chemistry, and so my tutorial is for programmers, for the hardcore programmers, C, Java, Python, Golang people. So anyway, so you go to string. So let's see string functions, string replace string pattern, test substring, get substring. Okay, so string take is take by position. String cases return a pass a string by regular expression. We want string replace. Okay, that's what we want. String replace part. Okay. Okay, we want string replace, which replace a string by a pattern. Okay, so actually we can use that. So the pattern is like this. Okay, so let's search for. Now we want to make sure is there always a space after semicolon. Yes, there is. See, there's always a space after semicolon, so we can just, or we can do a trim after. But anyway, so we have something like that. Game 100, replace it by empty string, and then the so for each of the lines. So first of all, we split by line. So map, okay, map to X list and by a function. So just like yesterday, let's write a function. Let's use the full syntax so people understand what we are doing. So function, so you map a function to this X list, which is each line, and the function the argument is X, then the function body will be X. Okay, string replace replace that game thing. Okay, so we don't care about efficiency, let's just run it. Okay, so here is the huge thing. Now we still have the word game 1. What's going on? No, we did remove it. Did we? Let's say game. No, we didn't remove it. Something is wrong. Oh yeah, we say 100. That's, again, we need a pattern. So a pattern, you need a regular expression here. So let's do it regular expression. Okay, so replace this string by regular. Okay, so instead of the game 100, you say regular expression, the full word. Okay, in Wolfram language, every computation is done by a function. So a function name, full name, not slash or whatever, cryptic crap. Okay, so the game 100. So what to represent a sequence of digit is \d, or is it /d, \d. So you add a plus sign. Plus sign means one or more. Okay, so one or more digit followed by a colon and space. Okay, so let's run it. Syntax unknown string escape. Okay, this is wrong. Unknown string escape. Why is it double slash then? Oh god, this is, yeah, it's double slash, just like Emacs. Okay, here's the interesting part. Just in Emacs Lisp and in general in Lisp, Emacs Lisp, Scheme Lisp, Common Lisp, they don't have a special, when you use a regular expression pattern, in other languages, that pattern is a special string, have a special meaning. Okay, but in Lisp and Wolfram language, you don't have such thing. A string is always a string. So in a string, if you want \d, you have to put a backslash in front of the backslash. So \d, that means matching any digit. Okay, so this is how it is. So for example, we can now, it works. So we can take the first line. Okay, run it. It'll show the first line, right? So you can see the game is gone. Okay, So once you do that, you remove the games. Now let's see, go back. You remove the games, then you split by semicolon again, okay? Then you split by semicolon. So once you have this, then you split by semicolon, okay? So again, string split. First of all, is a string. Second argument is what you want to split by. In this case, semicolon. And usually we should put a space because all the input have a space. But in case they don't have it, let's use trim instead. So check the documentation for split string and check if there's an option that automatically removes white space. Or we can use regular expression again. Okay, so let's do it. Okay, regular expression, then semicolon, space, 1 or more, 0 or more. So 0 or more is that. Okay, so split string by that, then the string will be this expression. Okay, so Wolfram language, again, it's all nested functions, just like Lisp. Okay, so and we can show the first line result. Run it. Incorrect. It should return a list. Oh, it did. Okay, fantastic. You see, it returned a list, but you see, one of the issues is that Wolfram doesn't print the quotes, so that's why you got them. Okay, so if you want to show the quotes, let's see. Let's print it. Okay, so there's a print function. You actually print it explicitly. Run it. Oh yeah, now it's printing. Okay. Now wait. So you have to say input form. Okay. So actually, let's remove that. So let's here use a postfix notation. That's like Unix pipe // Okay. Now you say input form. Input form is a function that takes a whatever expression and print them in a input, the way you type them in. So run it. Invalid syntax. Okay, so yeah, this needs to go into one line. So normally in Wolfram language code, you don't arbitrarily add a new line. Okay, you cannot do that. Okay, typically a new line implies is an implicit multiplication. Okay, however, in places that make sense, such as this is a function, so wait, so you can add a new line here. Okay, so if you now run it, that will work. Okay, wait, the input form doesn't work. Well, that's because well, okay, so let's run this in Wolfram language in the notebook. Let's start. Shiko says string position. Okay, Shiko is a Wolfram language programmer. Fantastic. That's an alternative way. So there is Wolfram language. I mean the Wolfram notebook. Let's move it here, and let's magnify. Okay, and let's. Okay, so first of all, we have 100 lines of input. Then we have, then we run this. Okay, so now notice very nice formatting, automatic. You see these double brackets right here. That's when you paste it in, it becomes this thing. So it's very nice. Auto formatting. Okay, and also when you shrink the window, you can see, okay, let's put it apart. So delete that, put it here. So now when you shrink the window, God, too many input above. Yeah, so I cannot show this properly. But when you see, they automatically format in a nice way. So why don't we open a new window? Let me just show you here. You see the indentation? You see? That's why in Wolfram language, you don't manually add line return like the idiotic coding industry, C, Java, Python, or the whole thing. Style guide. You should not have longer lines than 80 characters. The fucking extreme idiocy. Now look at, so when you have that style guide and that concept in your mind, that tradition, that formatting, you will never develop this technology. Okay, I talked about this many times to programmers. Wolfram had this for 20 years, 25 years by now. The average industrial programmers don't know. They don't know what you're talking about. I did a video about this line, I ranted about this, and I did 2 live streams at least. And the industrial coders, including some in our XR forum, they don't know what you're talking about. Anyway, so this is interesting, okay? So let's back to, so let's evaluate this, okay? Shift, enter, so evaluate it. Now let's run this code, shift, enter. There it is. Now you can see you see it's a list, but now it prints the quotation sign. So you have a list of 3 things. That's the first line, okay? So, but if you are running Wolfram script in the, let's run it. So you see, if you are running Wolfram script, it doesn't understand the input form. So this is a reason you want to pay to buy Wolfram language, okay? Get the hobbyist version, which is discount. Okay, so we got that part. So we split the lines. Now we just check. God, now we need to extract the numbers. Okay, so question: are the list numbers always in particular order? So we have blue, red, green, but here is red, green. Okay, so you cannot rely on order because sometimes there's just one color, okay? So I'm thinking, so you can use a hash table, a dictionary, to store how many is green. Green, the color is a key, the value is a number. Yeah, that's the easiest way, okay? So let's go back to the problem. So what is our problem? Yeah, so we just need to know. If any of these number is greater than. Yeah, okay, so here's also the essential input. So we need also an essential input. Let's see. Now let's see what's the actual input, because so far as I know, you need 2 input. One is the game record, the other one is how many things in the bag. So let's get this is already the real input. Okay, but for the toy input, do we have the toy input? Yeah, okay, so let's copy the toy input as well. So here is the toy input, and let's just make it, okay? So for the toy input, the solution is 8, okay? But now you also need this. So again, the advent of a code, they do not have a very specific requirement for input. So you can encode this input any way you like. So let's directly put into a hash table. Okay, in Wolfram language, a hash table is association. Actually, association is pretty new. I haven't used that much. Yeah. Association or hash table or associative list is added to Wolfram language around 2015 or something, after 2010. So it's added pretty late because Wolfram language doesn't, but anyway, that's another story. So let's add association, okay? So red 12 basically. Let's just do this, okay? 13 green, 14 blue, okay? Okay, that's the total bag, okay? Let's say big bag. Run it. Good. That tells us at least our syntax is correct. So now we have the association. Now we can check if let's check, okay? So if I have, let's say I want association. Now I haven't worked with association much, but let's just solve this problem, okay? Let's go to, I have some tutorial about association I started to write. Association key value pairs, okay? So now we want, how do you get value, okay? So there are so many ways, okay? I'm not too familiar with this. Okay, lookup is what you do. Let's just say bag, okay? So lookup in the bag and the key, let's say red. If it doesn't exist, let's say let's just say 0, 1, okay? Wait, let's just say if it doesn't exist, let's say false, okay? Now run it. 12. That's correct because we have 12 red, okay? So this is how you get the value, okay? So now becoming very simple. So here is, so this is the lookup code. Now so far we have a list of colors. Now we want to turn this list of colors into an association, into a dictionary. Okay, so we have a list of colors. Now we need to turn that into association. Now there are many ways to do it. Okay, I'm not sure which one because I'm not too familiar with association. So how do you turn this? Usually very easy. So let's try. Let's just, okay, let me just try something here. Okay, so suppose this is your thing, and okay, so this is our real code. Now before that is testing code, okay? This is just our toy, like testing some Wolfram language stuff. So now we want to turn this. Okay, how do you do that? And this is lookup. Okay, so here is a lookup dict, and now we want to turn this into a dict. How do you do that? So you can string split by regular expression, comma, space, one or more. Okay, get rid of the space. Okay, so you got a list. Then for each, so you okay, here's what we can do. Create an association. I should have a shortcut. But anyway, create an association inside. Again, remember the argument should be a list of rules like this. Okay, so here is a list of rules. So what you do is you put this inside, you split them first. So the first element is like that, a string. Then you can probably do it easier but let's just push on. Okay, so you split again, and this time you split by a space. You split by a space. Okay, so you split by a space, then you reverse the items. Look up documentation, reverse the order, that's right. Then you reverse, then you add then you can just add once you reverse and change the head to rule. Okay, so okay, this is getting complex. Then you change the head to a rules. Yes, change the head to rules. So okay, this is probably not comprehensible to you guys, but so change the head to rules. That should be it. Okay, so this will turn a string like that into a dictionary. Okay, so we can run it. Okay, syntax rule. Okay, so we got a problem. Rule code with 3 arguments. Okay, rule code with 3 arguments. Let's see, why is it 3 arguments? Oh, you need to map, not right. So you need to, okay, so you need to yeah, okay, I don't think you guys can understand, but it will take a while to explain. Okay, so actually you just need a third arguments, 1. Okay, so there. Okay, run it. There it is. So you can see this second line that is the dictionary. But however, we got the order incorrect. Why is the order incorrect? We split by, let's see, 4 red, 3 blue, right? So we need to reverse it. So we got, so which line is this? 4 blue, 7 red, 5 green. 4 blue, 7 red, white, green. Which line is that came from? First line, okay, first line in the real input. Okay, so right, so why is it not reversed? We just applied reverse. Run it. Yeah, it should be reverse. Why is the reverse not work? Remove it. Oh. Okay, so let's try this. Okay, so let's try this. Okay, so actually level 2, I think. Yeah. Okay, this is the real association. I mean, you know, so if you say not associate. So the printed representation of this dictionary is that. So you see red 12, green 13. Now, however, this is what we get for this part, which is wrong. That is because we can try this. Okay, so okay, this is getting incomprehensible. I think for you guys. Tucito's been programming for a long time. Hi, how do you become this good at everything? I'm not good at everything. I'm not good in lots of things. Okay, so let's get back to this. Okay, so now let's replace that. Okay, now let's see. Now if we take that and okay, actually, okay, so okay, so so if we have a list like that, then we apply, then we say level 1. That will get you what do you want to apply? What is the function you want to apply? The function we want to apply is rule. Okay, let's see what you get. You see, we get that, which is correct. Okay, then but then what you want to do is you want to attach association to it. Okay, do that. You see, so the purpose of this block of code is just to show that how do you turn a list of this thing into an association like that. Okay, so which is what we are trying to do with the but there is something. So this reverse needs to map it. Okay, so you guys probably don't understand, but there it is. You see, this is the first row of game 1, the line 1. Okay, so we got association. So anyway, we got a code. So let's just move on. Okay, so here is how you turn it. So the real code here, string split. Okay, so string split, then you need to split again. Okay, then you need to apply apply a rule, then association. Okay, that's how it is. You probably, this code is getting complex. I don't think you understand what I'm doing, but again, something is wrong. Oh yeah, you forgot to give the second arguments. Okay, so yeah, second argument here is regular expression. So again, if you write everything in the fully nested functional form, it's just like Lisp. It's kind of hard to understand. Run it again. Still wrong. This is when it's helpful if you code in the Wolfram notebook, because now you can see it automatically format, and you can click and it will expand by syntactical unit, so you can see where goes where. So this is first string split, then we split again by, the first time is by semicolon, the second time is by space. That's right. Then okay, so actually you didn't copy the whole thing. Yeah, that's why it's, you see, so that's one expression, that's one expression, that's one expression, then you reverse. So but yeah, so where is my error? let's see, association. Is the arrow coming out here or what? Yes, the arrow came out from here, but how did you become good? Okay, so what else? Can you move your Emacs window higher on screen? Oh, okay. Good. Okay, let me just concentrate solving this. Oh God, 25 minutes. This should be easy problem. Oh, I got the plate. I placed it in a wrong place, I think. So first string replace. Wait, is here should be correct. Then apply. You know, I'm thinking of using a shortcut notation, because if you use the full notation, then it's gonna like, you know, it's like Lisp. You know, it's like Lisp fully nested and hard to understand, but it's worse because it's not everything inside parentheses. The function name is outside the bracket. So if you write everything in this full way, it's harder to understand. So you can write in a shorter way. Why don't we just... So for example, instead of apply... Oh, you're missing... I know what's going on. You missed the apply level. Right, apply takes 2 arguments with the third argument optional. You say 1, okay? So run it. What? Attributes, attention, NF. 1 is not a non-attribute. What? When did we add attributes? So here is the problem. Rule add at. What is that error? Commutative is not a non-attribute. Okay. Okay, the error is extra new line. That's probably... Run it. No. Okay, this is not good. Okay, I'm just gonna start to... Okay, I'm gonna start to write a different way. Okay, so first of all, start string replace. Okay, string replace. I'm going to... Okay, so I'm gonna write it here so you can kind of see the above, you know, the original. So I'm gonna rewrite this by rewriting this string replace. Okay, so replace x. Okay, so this needs to be a function. So here is a lambda function. Okay, so the lambda function, then you split by this expression. Okay, So let's again make it a lambda, and here is your here's your syntax. This is not so good. Then you can just add. Okay, so this is a prefix notation, so you apply this function to this function. Okay, then so things become easier that way. Then you do again another function, add this function. Okay, so apply this this function, output, feed it to this function, output, feed it to this function, so the code becomes linear, so you don't have a huge amount of nesting. So now apply rule. Oh yeah, I got the problem is I got this one should be inside here. That is the problem. Okay, idiotic. So again, take it out. Again, a function. Okay, so another lambda, add. Okay, then the whole thing map. Okay, now you can put the whole thing map. So you want to map the whole thing. You can write it this way. Just okay. Then just take that. Okay, actually you might need a paren. Okay, so here is a bunch of functions. You I think it'll work. Okay, but first of all, you need to comment out this. Actually, you just move this inside, that'll work. Yeah. So test this one first. What? Okay, you cannot have the fucking stupid. What the fuck? Why is it make it one line? No, something is wrong. Now what about our new God. Okay, this is not good. String replace. So that's one thing, string replace, then replace again. Okay, that's the second thing. Then you split string again. That's right. Indentation issues. This is wrong. Okay, so this definitely needs to go inside. That's right. Then a function. Okay, so map function. Let's do it. Why is that? Fuck. Rule code with 6 arguments. Oh, okay. So you need to map rule code with 6 arguments. Let's look up the documentation for apply. Level spec. Oh, okay. Yeah, so I knew this should be actually that, okay? So this should be actually that. That means just level 1, not 0 to 1. Okay, so let's run it. Still wrong. Okay, so why is it That's right. Okay, that applies correct. You turn a list of pairs into a dictionary, and here we work on the real input. So you should get a dictionary of blue, red, green. Run it. That's right. Blue 4, red 7, 5 green. Okay. Now, why is this? We are just basically copying this association to here, and somewhere went wrong. So apply. There's apply. Rule. There is a rule. Check. Rule. Check. Then reverse. Then reverse string split. Reverse map at string split. Okay. Then you string split again inside it. Oh, okay. I think I know what's going on. Shit, this is easier problem than yesterday, but we got It's already 40 minutes. I know what's going on because we are mapping to the different levels. Because for each line, first of all, you split into each line from the input. Then you have to map to each line. You have to split each line so it becomes a list. Then you map a function to the list. Then you have to split again, each of the 4 red or 5 green into a list of 2 things. Then so you are mapping it wrong. That's why. So let's do this, okay? Let's just input, okay? So input, let's just simplify the code by rewriting the input. So the input now no. Okay, so line list, okay? So line list equals to where is our X list defined? Oh, okay. Oh, we already have a X list. Oh, okay, so what are we doing? So X list is a list of lines. So let's change name. So when it get complicated, the name helps. So X line list is a list of lines. Then you want to let's do this, okay? So you want to map this function to remove the game extra thing. So I don't like to do that because now you are modifying the variable, which is not functional programming. But then you can put this inside here, so that makes it better. Yeah. Okay, so now line list. Now we don't need this part, line list. Okay, simplify it. Now it's just X. Okay, now let's comment out that. So we got a line list. Okay, now let's rename it just lines. Okay, now it's just a bunch of lines. Okay, then you then for each line you split by a semicolon, you get each draw. So here is each draw. That's right. So that is each draw. So let's just okay. Let's do this. So it's so that makes our code easier. X draws is a list of draws of a line, okay? And okay, and here's the body. So getting very complex. I want to write this so everyone understand what I'm doing, because otherwise there's no point of doing a video, because I can just code it offline, then it's much faster. So pairs, that should give you pairs. Which is like four, which is like a list of two things: red 4, green 7, things like that. Pairs, okay. Then hello, very strange language. I have never seen this Wolfram language. Yeah. Then what? Yeah. Then you apply. Actually, then association. So what the rule does is actually what the rule does is that, so for example, you have A21, that's a rule, which you can think of it as a pair in a dictionary or a hash map, one element in a hash map. So in Wolfram language, that is written like that, okay? So for example, okay, so you have a list, each one of these is a rule, which is basically a pair. And the alternative syntax for this is just, so you don't write it that way, you write it this way. So alternative syntax. So this two is exactly the same. So but what we are doing is we have to turn a list of pairs like that into that. Okay, so that's what this part is doing. Then we add a dictionary to the whole thing. Okay, so so apply rule, that should be it. pairs. That's right. So what is this? So let's go to inside. So this module, so first of all is each draw. This is applied to x. X is one single line. So let's make it clear. So this is one single line of string. Then you split them, it becomes a list of draws. Then you need to map this, okay. Association thread. Yeah, you see, I'm not too familiar with the. Yeah, I think you are right. Association thread. You know, these are new functions since 2015 or so. Association. Yeah, that's what key value. Oh, okay. Well, if you do this way, then you have to transpose the. You have to put the color names in one list, the value names in another list. So I don't think this. I mean, you could do it that way, but I hate it that I'm stuck here. But basically, we are mapping to the wrong because there are several map. Okay, so anyway, so X draws is a list of draws. So now you actually need to map to a list of draws. Okay, so that's why this is what we are missing. Okay, so map to level 1 by default. Then you map to each draw. The draw are strings. Okay, so actually getting more and more elaborate. Fuck. So you map a function to each draw. Yeah, so so you each draw string, you split the draw string. Then you got a list of draw, you split them, so each draw is several colors and number. Color number. Then you each draw string. Then you split it by space. What? You don't split by space. You split by comma. You forgot a comma. Where is the split by comma? Oh God, that's why we're missing a split by comma. Comma. Draw a string, split by comma. Okay, so what do you get? What? Okay, so that's a lambda. you take the drawstring, then you split by comma, then what you get is colors and number. Okay, so actually getting very complicated. I mean, this is not complicated, but it's just so now you got color. A color is a list of strings. Each string is like 3 blue, 4 red. Okay, then you map on to colors. Okay, right, so then you map to the colors by a function, and so in order to do that, you have to split string. Okay, split string. That's right, that's that part. Map to the color string. This is not a good name because color, people think it's just color, but actually it's a color and a number. Num color pair. So colors should be num color string. Okay, idiotic. Now it becomes elaborate with documentation. Just so drawstring example, that example, then num color string, then you get pairs, drawstring, then you get pairs. Naming issue, naming gets very complex. Okay, so you got pairs equals to, okay, reverse that, then you create association. Okay, something like that. Something like that. I hope it'll work. Getting very complicated. Run it. Ah, fuck. Oh, this is not good, man. Can you move your Emacs? Okay, very strange language. Maybe association thread. Okay, Advent of code is very nice for learning new language. This year I'm trying Rust. Seems very popular now, right? Hello, I have a Wolfram language question. I wanted to read data from a YAML file, and it seems that Wolfram can only read JSON, even though the conversion is usually simple. YAML file, is that indentation based? Well, then in that case you have to write it, or look at the Wolfram library to see if someone already wrote it. Otherwise you have to do parsing yourself. but maybe the best thing is first to convert the YAML to JSON by some other tool. Yeah, because there are so many of these formats. I don't think Wolfram supports YAML. I'm not sure, but I doubt it. If it's an image format, there are tens of image format. Wolfram supported all, and also animation codec. Movie video codec. Wolfram supports tens of them, or 3D formats. CAD, 3D different movie, 3D format. But for YAML and those, I don't think. Yeah, you better just convert it to JSON first, or just write your own parser. But with the indentation-based notation, that sucks. It's not trivial to write a parser for that. So let's get back. Oh God, this is not good. Now it's 1 hour, and we stuck on this like no problem, and I really like to take a break. I need to take a walk. The problem happens in part is because I'm just coding and coding. I'm not thinking. Usually you take 5 minutes, don't talk, just think. You find the problem, then you can code it, like you can fix it. You can find out where you got wrong, but so that is why. So, and now the code becomes so complex, so complicated. Like I don't, if you are not familiar with Wolfram language, you don't know what I'm doing. So it lost the value of live demo. And there shouldn't be a semicolon there. Let's run it. Yeah, something's wrong. Rule syntax, rule code with 3 arguments. Yeah, that's not good. So why is rule code 3 arguments? Let's just not, instead of apply rule, let's just rule map to. This is much simpler. Okay. Maybe we should do this long ago. Yeah, rule code with an argument. Where is the problem coming from? Let's stop that. Wait. Let's comment out that. Yeah, comment out that. Run it. Comma encountered. Okay, here I think I got a problem with running long code in Emacs because you don't know what line or stuff error came from. Comma encountered with no adjacent expression. Okay, the expression will be treated as null. No, something is wrong. So it says comma encountered. Okay, where is that? Yeah, because I'm just talking too much. What? What to do? So module here, module is just like Lisp's let. It just lets you declare local variables. So we declared, so here's a module. If we can delete the whole thing. So we basically just want to map this function to a list of lines. Okay, and what's inside the function? So the function takes 1 argument, x, 1 line. That's 1 single line of string. Okay, then the function body is this thing. Okay, so the function body is a module, which is like a block of code, like the C's braces. Okay, and in the first argument of a module is a list of variables you want to declare locally. So that's why we have this drawstring. So let's go over. So So drawstring is a string that is like 3 blue 4 red each draw. Okay, so we what you do is you take the x1 line is a string of a line like that which contains many draws. You split by semicolon, then you get a list of draws. Okay, so that's why it's a string. Better name it draw. Okay, yeah, well, it is a string, so draw is a string. Okay, so anyway, then so you got a string like 3 blue 4 red, then you split string, you map split string to the drawstring. Wait, drawstring, is that just one or many? It's many. Yeah, so drawstring is many. That's why you need to map it. So it should be drawstrings. Right? Drawstring is a list. Wait, so it's not a string. What are we? God, this is so confusing. Drawstring is a list of draws. So each element is a string, but the whole thing is a list. So it's a list of strings, and each element is like 3 blue 4 red. Okay, something like that. So the name is incorrect, so it should be just draws. Okay, so let's rename it. Okay, then we work on the draws, which is a list. So we map some function to it, and this function again split string by comma, so that you got a list of each color and number. And so this value, this variable should be a list. It is a list, and each element is a string, and that string has a value of something like number and color. Okay, so this number color string is not a string, it's a list. Okay, it's a list of strings. Okay, so let's rename it. Pairs. Okay, so number pairs is a list. Each one is a string, such as 3 blue. That's right. Okay, now this is a list, so now we again map to the list. Okay, we map to the list here, and we map it by this function again, split string. Now this time split on space, so we got a pair 3 and blue, or 4 and red, a list of 2 things. Again, they are strings. The first element is a number in a string. The second element is a color. Okay, you map that, then reverse is wrong. Then actually you can put the reverse inside the map. So you reverse it, then actually you just put a rule in front. Then actually, yeah, you don't know what I'm doing. You replace the head by rule. So then you just say association pairs. Okay, let's see, let's copy that in Wolfram language, paste it. Let's see where does the, yeah, so reverse and that are connected syntactically. Then the rule add means replace the head, replace the list by the rule. So anyway, run it. Something is wrong in my code, and I don't know where. Yeah, this is very bad. This is really bad. So let's run in Wolfram language. Okay, let's see what happens. Run it. Okay, then xbag. Do you have it? Run it. Okay. Now X lines. Oh, there. That's fucking up the thing. Why do we have that there? Yeah, so wait. Minute. Still not wrong. Still not correct. String split. Expected. So we missing an argument. Basically, our comma is placed in the wrong place or things like that. Let's see. Let's run them one by one in Wolfram language. Okay. So this lines works. So this is a line. That's right. This is a line. This is a line. X lines. Okay. So then what? Okay, that shows you the lines. Okay, table form lines. Yeah, God. Okay, then what you do here is you have this thing. You want to map. Oh, the map. Wait, it's a function, right? Yeah, it's a function. Why is it not? It's much nicer looking there. So string or list of strings expected at position 1. Okay, I know what the, so where does this one came from? A split string. Okay, I think I know what's going on. So you need to move this inside. Okay, run it. No. This is very bad. Let's see what this returns. Okay, so now, so you can see, this is what we get. The pairs. So this is the first input. Okay, so now we are going somewhere. So this is actually the first input, like that. 4 blue, 7 red. 4 blue, 7 red, 5 green. Okay, let's copy it here so we can see. Okay, so that represents the first line. 4 blue, 7 red, 5 green. Okay, check. Okay, then right, so we want to map rules at that, and let's see. So this is output. So each element is a draw. So can we haha Huang, this is too bad. It's 70 minutes. So we Thank you for documenting Ergo keyboards. I bought Glove 80. Great. Thank you. So so this is not good. I don't know, maybe another 10 minutes we'll probably finish the part 1. Then there's part 2. So it takes a few hours. That's not good. Because now this day 2, the problem is still pretty simple. Pretty easy. I remember last year, I kind of stopped. I stopped at day 6 because then it took 2-3 hours and stuck in the middle. But I presume that's actually easy. That's actually normal because, I looked at other people doing this advent of code. Even if you are a professional programmer, taking a few hours is normal. So unless you are the competitive, the gaming, the competitive speed coders, those people are no good actually. So, but basically for those people, they focus on getting the code out the fastest way possible. I think in the past 10 years, they started to have that kind of competition. Let's see who can write the code the fastest. But I think that's some skill, but that's not a typical skill for professional coders. Especially if you are great, writing great architecture for great giant software, such as Google search engine or spaceship software, things like that. And, if you are winner of those speed coding competition, that's some skill, but that's not a typical skill for writing great, huge software. I think the situation can be comparable to there are math calculators, human calculators, or they can do incredible feats of mental calculation, like 20-digit number, multiply or square root or 10th root, and they can. But typically those people are never great mathematicians. Like if you look at history of mathematics, those great mathematicians usually are unable to do that, except a few. A few are both. They can do mental calculations and they can also do they became great mathematicians. So similarly for programming, anyway, I'm digressing. So so I think few hours is common, but so what am I going to do? The day of code. The giving up is the easiest answer, and let's do something else. Yeah, but I think we are going to continue advent of code for a few days. But for today, let's see, should we continue? What do you guys think? I think not many people watching, 4 people or something. We can either continue, 9 people, okay. So what about this? Let me finish doing the part 1 at least. So then, because it's almost done. So then we move on to, then I'm gonna stop. then maybe tonight we continue. I do another video maybe to continue part 2. I want to finish it, so let's finish it. So okay, so now we know where we are. We got this thing. We and my code so far is not looking good. It's not. It's fairly complex. It's okay. So we got that. Pairs. This is still for one line. So you want to. So yeah, the problem is we got a nested list of things. So what do you do with pairs? Okay, so this is actually the whole thing is just the first line. Remember, the whole thing is actually just the first line. Okay, one line you have several drawers, and the way we are doing it is okay. Let's push on. So the pairs is a list of pairs, but also inside a list of drawers. So that is a problem. That's where. And reverse does not seem to work. Number pairs, X number pairs. Let's comment this out. Let's run it. 5 green, 7 red. I think I should start again. Current code is too confusing. Oh God, I'm gonna stop. I'm getting fucked up. Yeah, I don't think you guys can read this. But it's really simple though. I mean, it's really simple, but this is not a good, and maybe if I do it in notebook, Wolfram notebook, it would be clear. It would be clear, more clear. Well, it's 90 minutes. Fuck it. Okay, here's what I do. Okay, we're gonna come back in 3 hours. Okay, yeah, let's do it in 7 o'clock. So now it's 2:30. 3, 4, 5, 3, 4, 5, 6, 7. In 4.5 hours, we come back. Okay, so when we come back, we can actually, I'm gonna finish it offline. I'm gonna do it part 2 too offline. Then come back, I might, start over, and it should be pretty, once you go, you do it, then you explain it's, it's easy. It's like, so let's do that. Yeah, but right now the problem is like the nesting is becoming annoying. Okay, that's it, guys. Thank you for watching. So we come back at I'm gonna post 4.5 hours. Can you put the current state in the blog page? Okay, yeah. So so if I put in the current state, the current state is basically it's basically the nesting. It's kind of confusing. So you got a line. A line is made of several drawers. Okay, and a drawer is made of several pairs of number and color. Okay, then each pair of number or color, you want to process this. You want to process it. You want to reverse it and put it into a dictionary. So anyway, a line is several drawers, and you want to eventually go through each drawer to see if any of the number is smaller. I mean, to see if any of the number is greater than the given number of cubes. Okay, so for example, if there are 12 red, so if any of the draw you got 13 red, then immediately that whole line, so-called game, is eliminated. Right. So my problem right now is just I got confused with which part is a draw, then which pair, which is the pair, is a list, or did we reverse it? I mean, so that's where we stuck. Okay, so if we put this code back, okay, in browser, let's just do it. Yeah, actually we in the beginning code, I think actually I'm somewhere. Then we started to clarify. In either case, it's not going to be clear because you have several levels of nested map. Okay, this is the issue you have with functional programming and Wolfram language. If you do it, if you do a loop instead, which is typical in C or Java kind of, then you use variables to annotate each line what you do. Then you do it procedurally. But our current code, even it's kind of complicated, and I try to anyway. So I'm gonna put this up. Okay, yeah. Let me put here. Start again at 7 p.m. San Francisco time. Okay, so let me put that into my blog so you guys can see, and I'll upload it in 10 minutes. But for now, bye guys. Thank you guys. Sorry about that. Okay, I'm gonna upload it. Bye.